little video now that shows how the EEK from Elektor can be combined with the Arduino IDE and with assistance from Anthropic's Claude AI assistant, the free version actually, to generate examples for the EEK board. And we're going to focus on one of the basic examples that's in the book and in the course, which is to do a gesture analysis of the EEK as it's rotated around its axes, both vertically and horizontally. So I'm running now a little sketch in the Arduino IDE, which is kind of one of the basic sketches, which I call gesture tester baseline. And then if I can show just a little bit of the motion here, the LEDs will light based on how I position the board around its axes. So let me try that. So I was not talking there because my microphone was too far away. But the LEDs lit as I rotated the EEK board. And again, this is a hand-generated example. I learned about the MPU 6050 really a couple of years ago now. And this is one of the examples in the book. So I'm going to start with a new Claude project. So this is the macOS app interface version of the free plan. So my moniker under this free plan is Dr. S. And so I'm running that version of Claude. Just do an about here just to see what version there is. 1.1.2998. And the Claude app is being revised almost on a daily basis. So we're still kind of in the midst of the app being born for us out here to use. And this is the latest and greatest version of the day I'm doing the recording. So again, I'm not here to explain Claude. I'm just kind of here to show how it's used. And the way I'm going to use it now in this video, rest of this video, is I'm going to go to my project selector for Claude. And then I have 4 projects. The free plan allows you to have up to 5 projects. So I'm going to create a new project. And I'm going to call this project something. So I'll call it Elektor EEK Claude Demo. And my purpose for this project is to use Claude to generate new EEK examples. Excuse my typing. So I'm going to create that project. And so this gives me a new conversation window or chat window in which I can start to talk to Anthropic Claude. I misspelled. I'm not going to go back now, but I misspelled Claude to Claus. We'll leave that little glitch alone for now. And the way I want to start this is I want to upload some context files for Claude to use to help me generate examples. And so I am going to click this plus arrow and then select Add Files or Photos. And then I've been here before, so my picker picks where I was, Claude Demo. And then these are the 3 files I want to upload to Claude. And then I want to just open this selection of files. And so these are going to be project files for the rest of the conversation I'm going to be having with Claude. And the way you upload those is you use the up arrow to the right of the chat. And so it's now actually having read all of those files, it's coming up with this summary analysis of what it has read, what Claude has read from those files. And these are just basically ordinary files, which I can take a look at right here. So this is the summary text file, and it describes features of the EEK that Claude may use to give answers to questions or chat requests. Then there's another file, which is the JSON file that gives more specific technical information about things that occur on the EEK. So switches occur, LEDs occur. They are connected to GPIO numbered pins on the ESP32. And then the third example is actually a baseline sketch file for Arduino. Now, right now, with the version of Claude I'm using, I can't use the .ino extension for an Arduino sketch because it seems like Claude won't allow me to upload it. But basically, sketch files, INO files, are really just C++ files in their very nature. So if I rename the sketch file to be .cpp, then that file can be uploaded, and in fact, it just was. So the upload is complete. And if I scroll down to the bottom, then I can see a summary, a bit of information, both about the EEK, the components on the EEK, what pitch and roll are meant to convey about motion sensing or gesture sensing on the EEK. And then it gives me the option, well, what would I like to do with my EEK board? And it says I can help you understand code, produce new examples, modify gesture detection. And that's, in fact, what I want to do. So what I'm going to go now, though, is find where I saved some example requests. And I put those all in a spreadsheet. So this spreadsheet here, in fact, it has right now 23 or 24 different prompts I've been experimenting with on the EEK with Claude. I'm going to take this one here. I'm not going to read it line by line, but I'm going to just select the whole thing up here in the editing window. And then I'm going to copy it. And then I'm going to go back to Claude. And then this is the next phase of my chat. So I'm copying in that example into that next phase of my chat. So create that example, and I'm giving it directions, giving it some descriptive text, all in English. There's no code here at all. This is just English requests. And then now I want to upload this gesture suggestion. So now Claude is telling me that it thinks it's found an example that will meet my requirements. And it puts a little bit of text in the comments themselves in the sketch. And it's not using directly my sample sketch. It's actually using the EEK descriptors that I've given. And then it comes down to the end, it's made a choice so that it's only going to be doing roll and pitch at singleton. So I think this is slightly different logic now than what's in my sample code, because in my sample code I allow both axes to be detected in the OLED and also in the LEDs at the same time. So let's just try this sketch. I mean, I want to see what Claude has told me to do. And so what I do is I use the copy symbol on the chat right there. I click copy. Now I'm going to go to my IDE. And then I'm going to use the sketchbook, which is this folder icon, and then select new sketch in my sketchbook. This again is standard Arduino IDE behavior. And then I don't want the empty sketch. Oops. Previous segment, I accidentally closed the IDE. So I've reopened the IDE now, and I want to grab the code from Claude by clicking the copy button. Come back to the IDE, and then ask for a new sketch from the sketchbook. And then select all here, because I don't need the boilerplate. I need in the sketch that I just copied. So there is that sketch just copied, and I want to save that now under another name. Save as, call it Claude Demo V1. And then this is the code that we'll work with in the next segment. To make this video, I thought I could do the 3 prompts I was going to show as examples in a one continuous long video shoot, and that didn't work out because just previous to this, I closed the IDE accidentally. So let me begin with the result of the previous sample request, example request. And this is the end of the code, and then this is a feature description of what it's generated for me. And that all of that description looks to be right, except for this one message here, shows EEK level message when within threshold. Yet when I go up to the code, then there's a display line, which is what's writing to the OLED display on the EEK, that's going to print the subsidiary message, tilt greater than 10 degrees. And that's literally a mistake. It put that in there for no good AI reason, and that's a mistake. So let's just verify that this code is carried over to the IDE. I already made a copy. Of the code, and I named it Claude Demo 1, and then that code actually is in in the compile here, and I've already compiled this and uploaded it to the EEK. And if I show the picture of the EEK, then you see that message is actually greater than 10 degrees, is on display there. Now, one thing as an expert programmer is I could see that line and delete it and then upload to the EEK, and then that problem would go away. But just as a demo, I want to go back and tell Claude to fix it. So I'm going back here. This is what it told me. So how shall I phrase this? You made a mistake. I'm just typing what I wanted to correct. The code has a mistake where a tilt message is printed when the EEK is level. No gestures. Fix this mistake. Again, you don't need to use please, but please fix. So I get an acknowledgement that I was right in seeing that change. And then now I'm looking to see that the code in the end of this is going to be is going to have the message removed. And I kind of have no doubt that it will have that removed. No, but it didn't do it right. It removed the EEK level messages along with the tilt greater than 10 degrees message block. So now the OLED display will be blank and the angle values will only appear when tilted beyond the threshold. Please return. This is actually, AI in error messaging that I was not anticipating, because this is the first time that this actually has happened. And I've done this kind of demo sequence like 5 or 6 times before. Please keep the level message. Yeah, so now it's just going to restore the corrected code. And again, we'll see when it gets to the last of the generation. Now, this is the way that the app works. You actually see the code being written to your display window in real time. And then that's the message that it should show when the EEK is level. So I think now if I go back to the IDE, and then that's show when message is level, and if I take this code that was just produced, go back to the IDE, and then just select all of this code, and then replace it with the newly generated code, then I will have that the EEK is level, a message only, and that wrong tilt message is going to go away. So this is not quite V1, because V1 had an error and then it overcorrected when I asked for the correction. So I wanted to put the level message back, and now that's what I've got. So I'm not going to actually push this code to the EEK and show that as part of the video. It will have corrected the mistake. I'm going to go on now to the next prompt to add some different behaviors. That generated code with one that uses pulse width modulation, which with basic Arduino logic, that means you change digital write to analog write, and you give brightness magnitude or levels rather than simply on or off values for the lights to be illuminated. So I'm seeing that the compilation is proceeding here. I'm seeing whether or not we have the analog writes are set up here. So that's kind of what I would expect rather than digital writes to turn off the LEDs. You don't use digital write 0, you use analog write. But again, the parameter is 0, which means 0 brightness, whereas completely on would have value 255 there. And now we're going through the upload process for the sketch, writing that to my EEK, which again is running, in that camera view. And then now I'm going to enable serial monitor. I'm going to restart the EEK just so that we have a fresh display. So now we have a fresh display of the EEK, calculating offsets, hold still, calibration done, and then the EEK is level. Now there aren't any other serial monitor outputs in the code that was generated. I do have serial monitor in my initial startup code, but I didn't tell Claude to kind of have messaging going to serial monitor as well as going to the OLED display. So now I'm going to try to pivot this around its axes, the long axis and the short axis. And you can see the blue LED gradually getting brighter as I made the tilt angle more severe. Let's do the bottom tilt. That's a little bit harder to see because the yellow isn't as bright in the camera view. Let's do roll left, which is x-axis. And you can see the red LED getting gradually brighter. And then I'm going to do the roll to the right, and then again the green LED is getting gradually brighter. And then you could have effects going on at the same time. And then when I'm doing those tilts, it's hard to see, but the OLED display is giving you actual values for the roll and pitch angles that are being detected from the MPU 6050. So now what I want to do as the final prompt in this demo is I want to take my original code and then have Claude modify it rather than have it come up with its own generated code. So it should leave everything in place except to respond to my request, as you'll see in the prompt. Looking at the screen from Claude, and one thing I kind of I ignored when I was showing the mapping to the code is that there is a fairly complex bit of logic that Claude introduces to do the mapping to brightness. And it describes it in its key changes summary. It says it's using the map function, which is an Arduino function, to convert the tilt angles to the PWM values, which is okay. That's kind of a standard way of doing conversions, and I use that all the time in the rest of my EEK example set. And then it also decides to use the constrain function to limit angle values to 11 to 45 degrees before mapping to brightness. And strictly speaking, that's not necessary. And the code that is described here is literally the code that's in the example. So I'll go over to the IDE. There I am, going to the IDE. And then, so there's that logic. The map function is used to go from min bright angle to max bright angle and mapping those values to 0 to 255. That's okay. And then it decided to take whatever the current angle magnitude is, which is the absolute value of pitch in this case. It's going to constrain that value to be between the minimum bright angle and the maximum bright angle, which is 11 and 45. I would have thought maybe you would make this into an Arduino function rather than using it literally inline in the code, and you repeat that logic for both pitch and also for roll. So that might be a little bit less readable from a more of an expert programmer perspective, but it certainly implements the situation as I described it in my prompt. So let's leave that alone for now, and then I'm going to go back to Claude. And then this is where I want to do the prompt that asks it to modify my original function uploaded to this project. So I can get that from the Excel spreadsheet. And then it says here, modify the code example uploaded to this project to use PWM, which is what we just saw in the generated example, for angle effects where a more severe angle produces a brighter LED instead of on or off LED when the angle is above the Z zone. So it's not very precise. I'm curious to see how this does. So I'm going to select the whole thing, copy it, go back over to Claude, use that as my next chat prompt. And then now this is not the previously generated example, but the code example that I uploaded myself. So let's see what we get from this entry into Claude's understanding. So again, it's modifying my code, the baseline code, to add in PWM-based effects. So I didn't say how to do that. Will it use the same kind of logic that it used before? That remains to be seen. My dead zones are not identical in the original code. Experimental use of the EEK said that maybe I could have different offset angles for a dead zone. Brightness mapping, preserve the dead zone values, plus or minus 15, plus or minus 10. I don't know what it's doing for. Yes, it's doing the same logic. So the brightness pitch, it's doing it in line, mapping on the constraint of the current value of the agnal magnitudes, both for pitch and for roll individually. And then that part of the code is the same. So, but it should be leaving my crude use of serial monitor to give the continuous feedback of when I'm tilting the EEK and getting the signal to do things with respect to actions it could take. Like if I'm flying a drone, I would want to continue, doing the rolls or doing the forwards or backwards that correspond to the gestures that could be used to control the drone. So I think this looks okay. I don't see any obvious errors. It's going to keep my own display logic alone. And so let's go and see what happens. Grab the code. Go back to the IDE, and then I'm going to get rid of the Claude Demo v2 just to take it off the screen. And then rather than have a fresh sketch, I'm going to take the baseline that I have in here as an INO file, and I'm going to remove it. And then I'm going to paste in the code that Claude just generated for me. So this is the overwrite that basically makes the change or the digital writes for angles and lighting LEDs are going to be replaced by PWM analog writes instead. But that should be the only change that is made here. So rather than overwrite the baseline, I'm going to do another save as example. And then I'm going to say gesture tester baseline. And rather than use that long suffix with copy, if I can get my mouse to behave, I'm going to say Claude and then PWM. So that way I'm keeping my original gesture tester baseline around if I want to compare the results. So I'm saving that. And then I'm still in that one window. It's replacing what was in that one window with the new example. And now if I go ahead and run this for my EEK, then the compiling should begin. And because I've been doing these kinds of compiles now, it shouldn't take very long. And all of the code, if I were to go back now and do a side-by-side comparison, this is the code that was mostly in my uploaded example. Some additional declarations are changed here. Pitch dead zone, roll dead zone, those are new definitions. What the max angle is, that's a new definition. But everything else is the same. My statements to the OLED display, my write statements to the serial monitor, none of those have been tampered with, one would hope. And instead of using digital writes, we're using analog writes, just like we saw in the original example. And then now that's the main loop, which is going to be doing my determination of whether or not my tilt of the EEK is enough to generate LED effects, and what those effects are in absolute value, or in numeric terms. I see those effects inside of the OLED display. So the compilation part is done, and now we're into the part where we're waiting for that to be uploaded to the EEK itself. And again, this should not take long. Yaw isn't used at all. Yaw is rotation, and I'm not actually trying to detect any meaning from rotating the EEK. And I probably myself should have gotten rid of that a long time ago. So again, this is now compiled and uploaded. And let me go and turn on the serial monitor. Let me find the camera view. There's the camera view. So once again, you see my messaging inside of the OLED display. And in fact, let me restart this. So you see the logo for the library, and then status is 0, and then roll and pitch are basically 0. Yaw, because it's not very precise, it moves around a lot as you exercise the EEK. But now what we should be seeing is analog effects or PWM effects on the LEDs themselves, and then the roll and pitch value should be updating, numerically. So let's just try that in terms of my motioning around with the EEK. So again, you can see that the blue LED is gradually getting brighter as I tilt that way. It's harder to see, but the yellow is getting gradually brighter as I tilt backwards. And then I can do the tilts to the left and to the right. So in terms of what you see on the EEK itself, this is kind of the same effects that the generated example that Claude wrote for us was showing in terms of physical reactions to the LEDs and to the OLED display. And I'm still getting all of those continuous messaging as long as I keep the tilt there. Forward, left, that's what FL means, and F means just forward only. Backwards only, and then I can arrange for things to be only roll left or only roll right. Again, that's the example now, modified, my gesture tester example from the book and from the course, modified by Claude to introduce analog write or pulse width modulation effects. So I think this video, once I put it together with the other parts, gives a pretty encouraging sign that the EEK is ready to be used in conjunction with AI assistance. And in fact, I don't need to use Claude Code, which is a paid-for product. You have to have a subscription to do Claude Code, which is actually nicer because you can work in a terminal window. You can work within Visual Studio Code. Here I'm working directly in the Claude app, and then I have to do a lot of manual cutting and pasting to move code artifacts from the displays that we see in the chat and move those over manually into the IDE. But once you kind of get used to the interactions that you make between Claude and the IDE, it almost becomes kind of routine. Your body and your mind is used to doing all of that. So let me close the video down now, and I'll put the parts together, this last part as well as the previous parts, and I'll generate something that is kind of continuous, showing the process through the prompts that I was wanting to show everybody as an inducement to buy the EEK, and then also use the EEK in conjunction with a free AI assistant that Anthropic puts out there.